Hello students. So today we'll do some numericals based on interference. That is the distance of bright fringe and the dark fringe from the central maximum. Okay. So these are the two formulas. This is for nth bright fringe from the central maximum, and this is for n plus 1th bright dark fringe from the central maximum. Okay. Okay. Two slits in Young's experiment are 0.02 cm apart. The interference fringes for light of wavelength 6000 angstrom are formed on a screen 80 cm away. Calculate the distance of the fifth bright fringe. Okay, so should know how the setup of this Young's double slit experiment is, right? So this is, if this is the source, these are the slits, right? And this is the screen. Distance between the slits is small d. Distance between the screen and the slits is capital D, right? So we'll write here, this is given, two slits are 0.02 centimeter apart. So small d is given 0.02 centimeter. Convert it to meter, okay, into 10 raised to minus 2 meter. Then the interference fringes for light of wavelength is given, lambda 6000 angstrom. Again convert it to meter. So 6000 into 10 raised to minus 10 meter. Okay, are formed on a screen 80 centimeter away. So this screen is 80 centimeter away. So this is 80 into 10 raised to minus 2 meter. Okay, so all are in meters. Now calculate the distance of the fifth bright fringe. So n is 5 and it is given bright. Bright means we have to make use of this formula. Okay, so y 5 is 5 d lambda upon d. Substitute this gets cancelled. We'll remove all the points and all the this hundreds or thousands. So I'll take 5 into 8 into 6, 10 raised to this 1 0 1 2 3 4 4. This will become minus 10, and this I can write 2 upon 100, correct? So 2 upon 100, 100. So that 100 goes in the numerator. So I can write here plus 2. And this is divided by 2. 120 into 10 raised to 6 minus 10. So minus 4 meter. Okay. If you want, you can shift that point. Okay. So if I shift that point, it will be 1 2 3 4. Next question. In Young's double slit experiment, the fringes are formed at a distance of 1 meter from double slit of separation 0.12 mm. Calculate the distance of third dark band from the center of the screen. Okay, lambda is given. So we'll write what is given. First is are formed at a distance of 1 meter from double slit of separation. So slit separation is given D 0.12 mm. Mm we have to multiply by 10 raised to minus 3 to make it meter. Then distance of 1 meter. So this is our screen distance because it is formed on the screen, right? So D is 1 meter. Then third dark band. So N is given 3. From the center of the screen, and lambda is 6000 angstrom. So convert it. 6000 means we have to take 6000 into 10 raised to minus 10 meter. Okay. So for a dark band, we use n equal to 2n plus 1 d lambda upon 2d. Okay. Now here you can't directly take n equal to 3, right? Because this is for distance of n plus nth dark fringe. Okay. So we have to, so we are given n plus 1, that is 3 is given, right? For this problem n is given 3, which is our n plus 1. So we have to take here substitution n equal to 2, that is we have to reduce it by 1. Okay. If this makes confusion, then there is one more formula, that is for that is by 2n minus 1 d lambda upon 2d. Okay, so you can use this formula or this formula. So our n is 3. So I'll write here dark fringe. So n plus 1 is 3. So n is 2. Okay. So we have to substitute here 2. We'll get the same thing. D is 0.12. This is 1. 6000. 10 raised to minus 10. Okay. So this is 4 plus 1, 5 into 6. 1, 2, 3. So 10 raised to minus 10 plus 3. 2 into 12. This will be 12 divided by 100. So here it will become plus 2. Okay. 5 by 4. 10 raised to minus 5. So 1.2 into 10 raised to minus 5 meter. Okay. Let's solve this. In Young's experiment, the two slates are 0.2 mm apart. Interference fringes for light of wavelength 6000 angstrom are formed on a screen 80 cm away. How far is the second bright fringe from the central image? Okay. So here we have to find second bright fringe. Okay. So let's write what is given. Two slits are 0.22 mm apart. So D is small d mm. 10 raised to minus 3 meter. Okay. Then lambda is given 6000 angstrom. Okay. And it is formed on a screen 80 centimeter away. 80 centimeter, which is 80 into 10 raised to minus 2 meter. Okay. N is 2. Let's write formula. So Y2, we have to find 2 into lambda into D So this is 1, 2, 3 plus 3 plus 1, and this goes in the numerator, so plus 3. Again this is also there, 2 upon 10, so plus 1. Okay. Eight. 10 minus 8 is minus 2. So this is minus 4. So we can take one point here. So this becomes 4.8 into 10 raised to minus 3 meter. Okay. So there is one more sub question for this question. Okay. How far is the second dark fringe from the central fringe? So everything is same. Only thing is we are given second dark fringe. So if we are taking the formula yn equal to 2n plus 1 into lambda d upon 2d, okay, that time you have to use n plus 1, the given dark fringe, that is 2. So our n is 1. Okay, so let's substitute n equal to 1 this in this formula. So this is 2 into 1 into lambda is 6080 into 10 raised to minus 2 upon 0.2 into 10 raised to minus 3. So this is 2 plus 1, 3 into 6 into 8 minus 10 minus 2 plus 1, then this is 3, so plus 3, again this is 3, then 2 upon 10, that is plus 1. 9 8 ja 10 raised to minus 10 minus 2, 8 2 minus 4, so this becomes 7.2 into 10 raised to minus 3 meter. Okay. Here some mistake I did, that is I have not written 2. Okay, so here 2 is there, I have to divide by 2. So the final answer is 3.6 into 10 raised to minus 4 meter. Okay.